Hello, welcome to my channel. We'll be doing question number 7, chapter 1 in mechanics. Okay, this problem is a bit challenging, I would say. So, what we have to do here, uh, the scenario is this. Uh, there's a flat ground and there's a ball over here. So, a footballer, he kicks the ball, football, right? And ball starts traveling towards the ball. And the footballer also starts traveling. Okay, the ball. Okay, I'll talk about the ball first. The football first. So initial speed of this ball, it was given as 4 meter per second. Okay, this is given. The ball starts. Yeah, this is the initial speed of the ball. Okay, and it is accelerating or deaccelerating at a constant rate of 0.5 meter per second square. So the acceleration is minus 0.5 meter per second square. Okay. The question issue is, so the ball will roll toward the ball and it will reflect back from the ball after striking the ball, and the player is also moving towards the ball. So at what time they will join again? So ball will move towards the player and the player will move toward the ball. So at what after what time he will meet the ball again? Okay, so for the ball, initial speed is this, uh, acceleration is this, and the distance of sorry, to the wall is 10 meter. Okay, this is also given, 10 meter away, right? Okay, so I want to know that how long it will take for the ball to reach from player to the ball. So how long it will take to travel a distance of 10 meter. Okay, so we do not have much information. So first of all, I would like to know what's the final speed over here. So VF, I would like to find out. Okay, so once I know VF, then I would be able to find the time as well. So in order to find VF, I will use this third equation, which is 2AS equals VF squared minus VI squared. So from here, VF is equal to VI plus 2AS and under the root. So VI is given as 4 plus 2, and acceleration is minus zero point 0.5 and distance is 10 meter. So, sorry, this is VI squared. So it's negative 16, not 4. Or I should say 4 squared. Let me correct it properly. Okay, I will write it 4 squared. So this is going to be 16 and minus 2, which is 10. So this is under root 6, which is 2.45. 2.45 meter per second. So this is the speed when the football hits the ball. Okay. Now, how long it will take to reach over there? I will use the first equation, which is VF equals VI plus 80. Rearranging this equation, T is equal to VF minus VI over A. So final velocity was, uh, if I leave it as it is, under 6 minus initial velocity was 4 and acceleration was minus 0.5. So this will simplify to 8 minus 2 root 6, which is 3.1 second. Okay, so 3.1 second takes for the football to reach the wall. Okay, in this time, the player will keep moving towards the wall. So the distance traveled by the player, right? This, since he is moving with the constant speed, so no acceleration, it is simply velocity into time. So velocity of the player is given as 2 meter per second. Okay. Uh, This in the same direction as, yeah, right. So this is 2 times 3.1. It is 6.2 meters. Okay, so imagine the situation. We have this ground and the wall, and player, he hits the wall. So this is the scenario when t is equal to 0, and the distance between these two is 10 meter. Okay, now at 3.1 seconds, what is the scenario now? The ball has reached the wall, and player has also moved over here, right? So now player has moved 6.2 meters from its original position. So now the distance between player and the ball is 3.8 only. 10 minus 6.2 is 3.8 meter, right? Okay, what happened after this? Now he will move towards the wall and the ball will come towards him. So sometime they will meet again, right? So we need to find out the how long it will take them to meet again. Okay, okay. So ball reflects back with the same speed. Okay, so now the initial speed of the ball, um, the return journey or after 3.1 second, I will say that the initial speed of the ball now it is uh, 2.45 meter per second. Okay, it's not specified, but I will assume that when the ball is returning back, it has the same acceleration. Okay, they're not talking about this acceleration in this question, but I will assume that ball will have the same acceleration. So, okay, so acceleration is minus 0.5 meter per second square. Okay, uh, so distance covered by the uh, ball as a function of time. Okay, how can I do this thing? So, distance is VIT plus half AT square. So in this case, the distance is initial speed is 2.45, and it takes time t plus half, and acceleration is minus zero point 0.5 and t square. Okay, so this is 2.45 t, and it will become plus minus minus, and this is half and half, this is 0.25 t square. Okay, now this is the distance from the wall uh, and to the ball, right? How far the ball is from the wall. Okay, but how far it is from this point, which is 3.8 meter from the player, right? So I would say that that distance would be 3.8 minus this whole thing, which is 2.45 t minus 0.25 t square. Okay, so I'm talking about the distance between this point and the ball, wherever the ball is. Okay, so this distance is given by this, let me call it S1. So this is S1 as a function of time. Okay, now the player keeps moving, so the position of player from this point onward, it is going to be distance. So don't be confused. I'm using this S again and again, right? So don't be confused that what's the meaning of this S and what's the meaning of this S and what's the meaning of this S. So this is the distance traveled by the player after 3.1 second. So again, it's had the same velocity, 2 meter per second, and time is t. Okay, so this is that we call it t s2. So s2 is the distance traveled by the uh, player, right, from this point. If I consider this point as time 0 for the second period. Okay, so now at some time they will be meeting each other. So this S1 and S2 will be equal. So I would say that this 2t would be equal to 3.8 minus 2.45t minus 0.25t square, right? So we need to simplify this thing and find the value of t. Okay, so it is uh, 3.8 minus 2.45t and plus 0.25 t square. So if I rearrange things, if I just bring 2t on the other side, so it is going to be 0.25 t square minus 2.45 t and minus 2t and plus 3.8 equal to 0. So 0.25 t square and minus 4.45t and plus 3.8 equals 0. Okay, so this is a quadratic equation. Uh, yes, so let's solve it. So t is equal to minus b 4.45 plus minus under root b square to 4.45 square minus 4a, which is 0.25 into c, which is 3.8, and divided by 2a. So 2 into 0.25. Okay, so this uh, gives us two values, 16.9 second, and the other answer is 0.9 second. Okay, you can see that the magnitude of the times, it takes 10 3.1 second to reach over here. So for the next time, it will not be, this doesn't look likely. Okay, we can prove that this is not correct, but just using the common sense, this is not likely. So this is the time, uh, second, when the ball comes to the player again. So if I make a sketch again, so at t equals 3.1 plus 0.9, so this is 4 second now. So at 4 second, the player and the ball, they meet again. Okay, the ball travel from ball to the player and player move from this point to where here. Okay, this distance, how much is this distance? We will calculate in a second. So the total time basically, which we need to find out, this is 3.1 plus zero point 0.9. So this is 4 seconds. Okay, now one last thing, that how much distance it has traveled. So for example, this is easy. The distance traveled by the player is 2t, right? So it is 2 times zero point 0.9. This is 1.8 meter. Okay, so 1.8 plus 6.2. 6.2 plus 1.8. So this is 6, 7. So this is 8 meter. Right? So basically, when they are 2 meters from the wall, then they will meet again, and this will happen at 4 seconds. Okay, so this question was a bit challenging, but one thing is important. At the end of the book, they are not giving the answer as 4 seconds. They're giving us 4.17 seconds, and I do not know honestly that how did they get this one. So either I have some mistake in my problem, in my solution, or they are wrong. So I don't know if you have any clue, please let me know as well. Thank you very much for watching. See you in the next video.